Also, I forgot to note on this client, because the main menu widget like reloaded, you'll notice the player stats was updated, but that's besides the point. Let's actually go back to game lift. Let's go to game sessions. Let's refresh here. Everything's terminated now, and as you can see, all the player sessions are inactivated, which makes sense. And then go to the events page and click on refresh. So you see the scaling event, the one after the first one that initially activated the fleet, but the one after where you set the desired amount of instances from 1 to 0. And I actually wanted to come here more so just to make sure that there were no error messages, because again, if you don't clean up the server process cleanly before you shut it down, and for example you don't call process ending, then you will get an error message here. But everything seems to look good. And as you saw from those client windows, neither of the players' wins and losses were updated because the server process was shut down before the game ended. So the HTTP request to the record match result API endpoint was never made, and we can confirm this in DynamoDB. So let's go there, and we're in the players table. So let's refresh the entries in here, and as you can see in here, the wins and losses didn't update. And if we go to the match results table and you refresh here, the last time we saw it, before we joined that last game, there were 4 entries in here, and there are still 4 entries here. So the record match result endpoint was never called. And everything seems to look good here. So let's close out of those 2 clients, and I believe we are ready to code the final parts of the game mode class needed for implementing manual backfill. 4 minutes is a lot of time for players to join that game and fill it with more players to have a full 2v2 match, in the case where we don't get one upon the initial creation of the match. With all that said, let's go back to Visual Studio, specifically the GameLift tutorial game mode header file. And the first thing that we are going to add in here is at the very top of the file. Let's define our own custom enum. And basically an enum is a variable type with a restricted set of values. So a good example is if you had an enum type called fruits, and you can list the different values for that enum, which could include apples, bananas, pears, and whatever other value you want to include. Now, we need an enum for the different types of game session updates that can occur. So when something happens to a backfill request, whether it's positive or negative, we need a good descriptive way of knowing the event that occurred. And we also need some custom values for that enum as well, such as whether or not a backfill request is currently in progress. So let's write up here enum parentheses, and then underneath that enum class, and we'll call this enum update reason colon uint8, and then underneath that a pair of squiggly brackets. And the name update reason was chosen because I want this enum type to represent the reason why our game session was updated, whether it was something that we did in the game mode class or something that was set in the onUpdate game session handler function. Now in the squiggly brackets, we can define the different values that this enum type can take. So the first one is just going to be a default value, because when the game session starts, I would consider that state as nothing has happened yet, no update happened yet beyond the game session starting. So let's write no underscore update underscore received in all caps. And next I want a value for letting us know that a backfill request is currently going on. So let's write comma and then backfill underscore initiated. Now the next 4 values that I'm going to write for this enum are based off actual GameLift matchmaking backfill events. So when the onUpdate game session handler function is called, one of these next 4 values will be the reason that it was called. So let's type comma and then matchmaking underscore data underscore data. Now this becomes the reason that the onUpdate game session handler function gets called if there was a backfill request for this game session and it was recently fulfilled successfully, meaning we were able to find players to backfill this match, and now they're in the process of joining the server. Now let's move on by writing comma backfill underscore failed. So this is the reason that the onUpdate game session function gets called if we had a backfill request and it just failed for an due to an internal server reason. So then comma backfill underscore timed out. This is the reason that the onUpdate game session function gets called if you had a backfill request and it just timed out, meaning we couldn't match the backfill ticket for this match with other matchmaking tickets and use some kind of combination of the tickets in the pool and then this backfill ticket to create a new potential match to backfill this match with. So the last one, let's write comma backfill underscore canceled. So usually this is the reason for the onUpdate game session function to get called if someone, usually the server, manually stops the matchmaking backfill request. And the last value that I want to add to this enum type is a custom one to tell us when there is no backfill request going on, because the server currently has the max amount of players that it can hold. So write comma backfill underscore completed. Now moving down to the fupdate game session state struct that we defined a while ago, let's now add some stuff to it. So first I want to make a member variable for that enum we just wrote. So type out u property and then parentheses e update reason, and then we'll call this variable reason. And similarly to the fstart game session state struct, I want to keep track of the players defined in the matchmaker data from the game session object passed to the onUpdate game session handler function. So let's actually copy the player ID to player member variable of the fstart game session state struct, and just take this line here where we define the player ID to player variable, copy it, and then go back to the fupdate game session state struct definition and just paste it in here. And let's go into the constructor and now give a default value for the reason member variable. So we're actually going to set it to equal to e update reason double colon no update received. And after that, let's go further down to the class definition. And let's add a member variable to the game mode class, specifically one of type ftimer handle, for calling a function to stop backfill for this game session if an active backfill ticket even exists after a certain delay of time. I will explain later why we need this, but for now let's just type out u property parentheses ftimer handle, and we'll call this variable suspend backfill handle. Now let's move down again and define some private member variables. But before we do that, I apologize because I should have paused and explained what we are coding now, which is backfill. And what is backfill? Backfill for games is getting new players to join existing game sessions that have room for more players. And in GameLift, there are two ways to achieve backfill. One is automatic backfill and the other is manual backfill. The reason that I did not want to settle for automatic backfill for this tutorial is that at the time of this video, I believe, correct me if I'm wrong, but automatic backfill only makes one backfill request at the very beginning of the game, if the game session does not have the maximum amount of players that it can contain. But after the start of the game session, backfill tickets are no longer made. So that is why I wanted to do a very simple and primitive example of going about manual backfill, so that you can get new players into your game throughout the entire lifespan, or as much of the entire lifespan of your game session. Now, this approach that we're about to do is not necessarily the best, but it can help teach some things about how backfill can be implemented for games hosted on GameLift. So with all of that said, first, when there is an active backfill ticket for the game session to try to get players into this match, we need to keep track of the ID of that ticket for when we need to stop backfill for whatever reason. So I guess let's go down here and type out u property parentheses f string latest backfill ticket ID. So as I mentioned earlier in the tutorial, when a match gets made successfully through flex match and a couple of matchmaking requests, a game session is made somehow, and in addition to that, the player sessions for the players are also made. And those player sessions start in the reserve state until the server activates those sessions by calling the accept player session method. Now, for this tutorial, I'm going to give the clients the benefit of the doubt in that they may take some time to connect to the server for whatever reason. It could be bad internet, for example. So I'm going to give the clients the full 60 seconds to join the game because that is the amount of time that the player session stays in the reserve state until it times out if the server never makes it active. So with that said, I'm going to define a couple of member variables. One is going to be a boolean that gets set to true when either on start game session or on update game session gets invoked by GameLift. In the case of on update game session, the reason has to be that matchmaker data was updated due to a backfill request being completed successfully. And in those cases, this flag gets set to true. Then I want to keep a counter going, which will be another member variable, for the amount of time we spent waiting for the newly matched players to join, which can go up to 60 seconds. And again, the reason for that is that we will periodically check if the amount of players we expect to be in the game is equal to the amount of players actually in the game. And like I said earlier, we will give the clients the benefit of the doubt, so this counter variable won't go past 60, but it can reach 60. So type out u property parentheses bool waiting for players to join, and then underneath that u property parentheses int time spent waiting for players to join. And as I just mentioned, we need a way to keep track of the players that we expect to be in the game based off of the matchmaker data, whether or not the on start game session or on update game session handler functions were called containing information about the newly updated set of players that are supposed to be in the match. And the players we expect in the game can always change, as when backfill requests are in progress, maybe when a backfill requests are in progress, because there can only be one backfill request for a match at a time. Maybe a player leaves and we have to redo the backfill request, or if the game is full, there are no backfill requests going on, and then someone leaves and we have to make a backfill request to fill for that player. So type out t map and then in carets of string for the key, and for the value it's going to be of type AWS :GameLift :server :model and player. And we're going to call this member variable expected players. Now let's define a few new methods. First, we need a new delegate function for the timer handle that we just defined for suspending backfill after a certain amount of time in the game. So let's type down here u function and then parentheses and then void suspend backfill parentheses. And then let's define some reusable methods for creating and stopping backfill requests. So type out here f string, because we're going to make this method return a variable of type f string, create a backfill request, and then in parentheses this method will take in 3 parameters. First one will be of type f string, and this will be the game session ARN. Next one will also be of type f string, and this will be called matchmaking configuration ARN. And then the last variable will be of type tmap, and then in angle brackets, or as I like to call them :carets, sideways carets, the key will be of type f string, the value will be of type AWS GameLift :server :model :player, and then this variable will be called players. Make sure that the type of the value in the map AWS GameLift server model player is in carets, not including the variable name like I just did. And then the next method will be for stopping the backfill request, because the method we just defined was for creating backfill requests. So this method will return a variable of type bool, will be called stop backfill request, and then in parentheses this will also take in 3 parameters. The first 2 parameters are exactly the same as they were for the create backfill request method, so fstring game session ARM, comma fstring matchmaking configuration ARN, but the last variable will also be of type fstring, and this will be called ticket ID. Alright, now let's go back to the GameLift tutorial game mode C++ class so that we can initialize these new member variables and implement these new functions that we just defined. Starting with the constructor all the way at the very top of the file, let's initialize a couple of those member variables that we just made with some default values. So starting with waiting for players to join, let's give that a default variable of false. And then as for time spent waiting for players to join, let's give that a default value of 0. Now, before we implement these new functions, I just want to quickly modify some old functions, starting with the begin play function, because we have to actually add logic to that on update game session handler function, and that logic will be very similar to what we did in the on start game session handler function in terms of parsing matchmaker data in the event of matchmaking data updated. And also, before I do start coding in this function again, I just want to temporarily comment out these hashtag if with underscore GameLift, and down here the hashtag and if compiler directives inside this begin play function while we are writing code in this function again, so that we actually get auto complete suggestions while we are typing, as well as syntax highlighting, since I noticed earlier that was not turned on while writing code inside these compiler directives. Once we are done making changes to this function, we will uncomment these 2 lines of code, but for now go back up to the on update game session handler function, and let's get the reason for why this function was invoked by the GameLift service by typing auto reason and set that equal to update game session obj.get update reason parentheses. Then let's check what that reason is. Now again, it can be one of 4 values, so let's check for all 4 of them individually by writing if in parentheses reason double equals AWS double colon GameLift double colon server double colon model double colon update reason double colon matchmaking data updated, and then a pair of opening and closing squiggly brackets. Now I guess because we're writing a C++ Lambda function, that Visual Studio isn't picking up on the auto completion for the squiggly brackets for this if statement. And then underneath that, let's type out else if, and then in parentheses copy the condition from the if statement, because this condition for this else if statement will be very similar. Instead of AWS GameLift server model update reason matchmaking data updated, it's going to be AWS GameLift server model update reason backfill underscore canceled, and then add a pair of opening and closing squiggly brackets, and then underneath that add else if in parentheses. Once again, just copy one of these conditions from either the else if statement or the if statement, paste it inside this new else if statement, and for the update reason, everything after update reason double colon, just get rid of that and replace that with backfill underscore failed, and then a pair of opening and closing squiggly brackets. And then lastly, let's add a final else if statement, so else if, and then in parentheses, again copy one of the conditions from either the if statement or the else if statements and paste it inside here, and everything after update reason double colon, just replace that with backfill timed out, and then a final pair of opening and closing squiggly brackets. Now, in each of these cases, we will be setting the reason member variable in our update game session state struct variable equal to the appropriate equivalent value in our custom eUpdate reason struct. So for the first case, inside this if statement block, if the reason that this function was called is matchmaking data updated, then let's set state arrow reason equal to eUpdate reason double colon matchmaking data updated. And like I just said, we are going to pretty much do the same thing in each of these 4 cases with some slight modifications, of course. So copy this line of code where we set state arrow reason, and then paste it inside of these 3 else if statement blocks below it. So after pasting these this line of code in these 3 else if statement blocks, go back to the first else if statement block. If the reason that this function is getting called is backfill canceled, then let's set state arrow reason equal to e update reason backfill canceled. So instead of matchmaking data updated, replace that with backfill underscore canceled. And we are going to make that slight modification in the other 2 else if statement blocks as well. So instead of setting state reason equal to e update reason matchmaking data updated, we are going to set it equal to e update reason backfill underscore failed instead. And instead of setting state reason equal to e update reason matchmaking data update, we're going to set it to e update reason backfill timed out. Now, in the case where the onUpdate game session method was called due to a matchmaking data updated reason, then that means that the backfill request was completed successfully and we are expecting new players to join. But how will our game mode class know who those new players are? Well, that's why we're going to parse the matchmaker data inside the update game session object parameter passed to this function and get the player data from that matchmaker data and store it in the player ID to player member variable of our update game session state struct. Luckily, we already performed this exact logic in the onStart game session handler function, so let's scroll a little bit up and copy a snippet of code let's copy a snippet of code in here where we perform this logic, starting from the line that says fstring matchmaker equal to game session obj.get matchmaker data, all the way down to the closing squiggly bracket for this if statement. So the last closing squiggly bracket before the squiggly bracket that closes the onStart game session function. So again, just copy that snippet of code, scroll back down to the onUpdate game session function and copy that snippet of code in the if reason equals AWS game live server model update reason matchmaking data updated, copy in that if statement block specifically after where we set state arrow reason equal to e update reason matchmaking data updated. So yeah, go ahead and paste it in there. And so there are a couple differences between doing this logic in onUpdate game session and doing this in onStart game session. So for example, if we scroll up a little bit here, for me it's on line 102, but whichever line where you set state arrow matchmaking configuration ARN equal to JSON object get string field matchmaking configuration ARN. We don't need to keep track of the matchmaking configuration ARN in this update game session method, because in this tutorial we will be working with one matchmaker at all times. So the ARN will never change, and we already get it once in the onStart game session handler function, so that is enough for us. Therefore, we can get rid of this line of code that says, as I said before, state arrow matchmaking configuration ARN equals JSON object get string field matchmaking configuration ARN. So just get rid of that line of code. And also up here, if we go a little bit up, for me it's on line 96, but the line that says fstring matchmaker data equal game session obj dot get matchmaker data, you'll notice another line of code with a red squiggly line underneath it indicating an error, kind of like the line we just got rid of before. That is because there is a small nuance difference between the parameters passed to the onStart game session function and the onUpdate game session function. In onStart game session, an object of type AWS game live server model game session is passed, whereas in onUpdate game session, an object of type AWS game live server model update game session is passed. So this is a pretty easy thing to fix. We just have to add another line of code before this line of code that sets matchmaker data. Basically, we have to take our update game session obj parameter and we have to get the game session object from it. So that's pretty easy. Just type out auto and we'll call this variable game session obj, and then we'll set it equal to update game session obj.get game session parentheses. And that is pretty much it for the begin play function. We can go ahead and uncomment those hashtag if with underscore game lift and hashtag and if compiler directives now in this function. Okay, now let's scroll down to the init new player function, because now players can join not only at the beginning of a game session, but after a game session has been updated through a successful backfill request. So when we are assigning the team property in the player state, which is a little bit down below, let's check if the update game session state player ID to player map is populated first before checking if the start game session state player ID to player map is populated, because the update game session states player map, if populated, will be more up to date than the start game session states player map. So copy this snippet of code inside the if start game session state.player ID to player.num greater than 0 block, and then paste it right above it, because the logic is almost identical. It's just that we're going to replace the start game session state variable being used with the update game session state member variable. So let's do that. For every occurrence of start game session state, replace it with update game session state. And I'm just gonna double click this word so that I can copy it, just to make this go by a little faster. So everywhere in this snippet of code here where it says start game session state, just go ahead and replace that start game session state word with update game session state. So I'm just going to do that, double click the start game session state word to highlight over it, and then you can replace it by just pasting it with the update game session state word. And with regards to the if statement below, the original one that checked if the start game session state player map was populated, just prepend the if with an else, because so that it says else if, because when a player joins a game, we will only be using the player map in either the update game session state or the start game session state. Now let's scroll down to the end game method, because I want to clear that new timer handle variable that we defined earlier. So just copy one of these lines of code that call clear timer, and then paste it after all these calls to clear timer, and then replace the value passed to the function call with suspend backfill handle. And that was the only change that I wanted to make to the endgame method. Now let's scroll down to the handle process termination method so that we can do a couple of things. So first, let's clear the same timer handle variable that we just added a line of code to do in the endgame method. So same thing as before, just copy one of these lines where we call clear timer, and then right below it just paste that same exact line and replace the value that you pass into the function called clear timer with suspend backfill handle. And second, if the server process gets interrupted for whatever reason and there's currently a backfill request going on, then we should try to stop that backfill request before trying to shut down the server process. So type out if in parentheses latest backfill ticket id dot len parentheses greater than 0, and then squiggly brackets. This is to check whether or not there's currently an ongoing backfill request. And then let's type out auto game session id outcome equal to aws double colon game lift double colon server double colon get game session id parentheses, and then let's check if this call to get game session id was successful by typing if in parentheses game session id outcome that is success parentheses, and then another pair of squiggly brackets. And then let's go ahead and get the game session ARN from this game session ID outcome by typing fstring game session ARN equal to fstring, and then in parentheses passing game session ID outcome dot get result, and then parentheses. And then let's get the matchmaking configuration ARN from the start game session state struct by typing fstring matchmaking configuration ARN equals start game session state dot matchmaking configuration ARN. Now, as for why we retrieve the game session and matchmaking configuration ARNs, the reason is that if you remember from when we defined the stop backfill request method in the header file, it took in 3 arguments: a game session ID, a matchmaking configuration ARN, and a ticket ID. So let's call the method now by writing stop backfill request and then in parentheses passing game session ARN, comma matchmaking configuration ARN, comma latest backfill ticket ID. And then let's surround this if statement block of code with the hashtag if with gamelift and hashtag end of compiler directive. So type out hashtag if with underscore gamelift and then hashtag end if where that if statement ends. And since we just called the stop backfill request method, let's actually implement that method. So scroll down to the bottom of the file and start by typing bool, because this function will return a value of type bool indicating whether or not the call to gamelift server stop match backfill was successful or not, and then write a gamelift tutorial game mode :stop backfill request, and then in parentheses, like we just talked about, this method will take in 3 parameters. They will all be of type f string, the first one being called game session ARN, the second one being called matchmaking configuration ARN, and then the last one being called ticket ID, and then just add a pair of opening and closing squiggly brackets. And the first thing we are going to do in this method is make an object of type AWS gamelift server model stop match backfill request, because you have to pass one to a call to stop match backfill. So type out AWS gamelift server model stop match backfill request, and then we'll call this variable stop match backfill request. And then let's set some properties in this request object to the arguments passed into this function. So starting with the game session ARN, type stop match backfill request dot set game session ARN, and then in parentheses pass in tchar underscore 2 underscore ANSI, and then in parentheses pass in star game session ARN. And then for the matchmaking configuration ARN, type out stop match backfill request dot set matchmaking configuration ARN, and then in parentheses pass in tchar underscore 2 underscore ANSI, and then in parentheses pass in star matchmaking configuration ARN. And lastly, for the ticket ID, type in stop match backfill request dot set ticket ID, and then in parentheses pass in tchar underscore 2 underscore ANSI, and then in parentheses pass in star ticket ID. Now let's actually call the method to stop the backfill request by typing auto stop match backfill outcome, set that equal to AWS gamelift server stop match backfill, and then in parentheses pass in the stop match backfill request local variable that we just made. And then let's finish this method by returning whether or not the call to stop match backfill was successful by writing return and then stop match backfill outcome dot is success parentheses. And then of course let's wrap this function code in the hashtag if with gamelift and hashtag end of compiler directive. So up here type hashtag if with underscore gamelift, and then down here type out hashtag end if. Now let's implement the method for creating a backfill request. So above this method, go ahead and type out f string, because this method will return a value of type f string, which will represent the ID of the ticket associated with the matchmaking backfill request for the match hosted in this game session. Now let's type a game lift tutorial game mode, create backfill request, and then in parentheses this function will take in 3 parameters, and the first 2 parameters will be exactly the same as the first 2 parameters in the stop backfill request function. So write f string game session ARN comma f string matchmaking configuration ARN, but the last parameter will be of type tmap, and then in angle brackets f string will be the type of the key, and then for the value the type of that will be AWS hold on here, AWS game lift server model player, and it will be called, the parameter will be called players, and then just add a pair of opening and closing squiggly brackets. Now the reason why you need a parameter of type tmap with a f-string key and a game lift server model player object for the value is that when you make a backfill request, you have to define the current players in your match manually. Game lift won't know the players currently in the match, so the server has to figure out who is currently in the match if it wants to make a backfill request. And then using those connected players, you can make a backfill request to fill the match with new players. Moving on to the actual logic of this function, let's first define an object of type AWS game lift server model start match backfill request, because you need to pass one to a call to AWS game lift server start match backfill, and that is how you initiate a backfill request for the match. So type out AWS game lift server model start match backfill request. We'll call this variable start match backfill request, and then let's set a couple of properties in the request object, starting with the game session ARN. So type out start match backfill request set game session ARN, and then in parentheses pass in tchar _2 _ANSI, and then in parentheses again pass in star game session ARN. And then for the matchmaking configuration ARN, type out start match backfill request set matchmaking configuration ARN, and then in parentheses pass in tchar _2 _ANSI, and then in parentheses again pass in star matchmaking configuration ARN. Now let's set the players inside of the request object by iterating through the map passed in and adding one player object to the request at a time. So first write out for, and then in parentheses auto ampersand alem, and then colon players, and then a pair of squiggly brackets. And then in this for loop, let's first get the player object from the key value pair that we are iterating on by writing auto player obj and set that equal to alem.value. And add that player object to the request by typing start match backfill request dot add player, and then in parentheses pass in player obj. Now we have everything we need to make a backfill request, so let's call the start match backfill function by writing auto start match backfill outcome equal AWS game lift server start match backfill, and then in parentheses pass in the start match backfill request object. And if the call to start match backfill was successful, then let's return the ticket ID associated with the newly created backfill request. So write if in parentheses start match backfill outcome that is success, and then parentheses, and then a pair of opening and closing squiggly brackets, return start match backfill outcome dot get result parentheses dot get ticket ID parentheses. But if the call to start match backfill was not successful, then let's return an empty string to indicate that something went wrong by typing else and then in squiggly brackets return double quote with nothing inside those pair of double quotes. And lastly, let's wrap all of this code inside the hashtag if with underscore gamelift and hashtag and if compiler directives. Alright, and the next function that we are going to implement is the suspend backfill function, and this is a function that will get called in approximately 180 seconds from the start of the game, because player sessions by default have about 60 seconds in the reserve state until they are either set to be active by the server or until they time out. So as a result, because in this tutorial I'm going to stick to the default 60-second time period, not going to change that, so in theory once new players are matched to this game session through a successful backfill request, those new players have 60 seconds to join the game. Therefore, I don't want players to get into the game when there's less than 60 seconds left in the game, because theoretically they may not have enough time to join the game. I'll talk about why this matters a little more later in the video, but for now, just right above this create backfill request that we just finished writing, void a gamelift tutorial game mode suspend backfill and then parentheses and a pair of squiggly brackets. Now, since this method is meant for stopping a backfill request if there is an active one currently going on for this game session, let's clear the timer handle for the handle game session update function, because once we get to that method very soon, that method will be modified to handle the completion of backfill requests, whether the outcome is good or bad. So we don't need to keep calling that method if there will no longer be definitively an active backfill request for the match. So let's write get world timer manager parentheses dot clear timer, and then pass into this clear timer function call handle game session update handle. And let's check if there is an active backfill request by checking the length of the latest backfill ticket ID member variable by typing if in parentheses latest backfill ticket id.len parentheses greater than 0 and then a pair of squiggly brackets. And if there is a backfill request in progress, then let's get the parameters that we need for a call to stop backfill request. So first, let's get the game session ARN by typing auto game session ID outcome equal AWS gamelift server get game session ID parentheses, and then let's check if in parentheses game session ID outcome that is success parentheses and then another pair of squiggly brackets. And if the call to get game session ID was successful, then let's get the game session ID by typing fstring game session ID equal game session ID outcome dot get result parentheses, and then let's also get the matchmaking configuration ARM by typing fstring matchmaking configuration ARN equal start game session state dot matchmaking configuration ARN. Now let's call the stop backfill request method, but also check whether or not the call to gamelift stop match backfill was successful by writing if in parentheses exclamation mark, so not stop backfill request, and then in parentheses pass in game session ID comma matchmaking configuration ARN comma latest backfill ticket ID, and then a pair of opening and closing squiggly brackets. Because if the call was not successful, then let's try to cancel the backfill request again after a delay. Although the call to gamelift stop match backfill rarely fails, this is just an extra safe measure. So type out get world timer manager parentheses dot set timer, and then in parentheses pass in the suspend backfill handle, and then comma this comma ampersand the function, this suspend backfill function, so a game lift tutorial game mode suspend backfill comma 1.0f, comma false, because we don't want this function to be called repeatedly. We just want it to be called once after a delay, specifically a second, so the last parameter will be 1.0f. And just to be even more extra safe, in case the call to get game session ID fails, knowing that there is currently a backfill request going on, then let's do the same thing. Recall this suspend backfill method again after a second. So copy this line of code that we just wrote where we called set timer, and then for the if game session ID outcome.isSuccess statement, right below its closing squiggly bracket, type out else and then squiggly brackets, and then paste that line of code inside that else block. And to finish this function off, wrap the code after the call to clear timer in the hashtag if with underscore game lift and hashtag end if compiler directives. Now for the last function we are going to modify, which is the handle game session update method. This will be, in my opinion, the most complicated logic of code that we are going to write in this entire tutorial, because there are so many situations to take into account, including when a game session starts, when you are waiting for players to connect to the server, whether these are the first players in the initial matchmaking request that led to the creation of the game session, or new players in the backfill request for this existing match, and when a backfill request is completed, whether it succeeds or fails. Now again, if you are happy with the last version of this project that we just tested with no backfill, don't worry, because we will have a link in the description below to a separate branch in the GitHub repository for this project that contains only the code for what you saw in the last test session. However, we will also have a link in the description below to the project with the backfill code. So don't worry if you missed something while watching the video, because there will always be something on GitHub that you can refer to. Okay, with that said, let's scroll up to the handle game session update method and start with the case that we coded originally, when a game session activates. So a few things happen here. We set a boolean flag equal to true so that we don't execute this block of code inside this if start game session state.status statement more than once, and we initiate some timer functions to simulate the start of a quote-unquote game. Since we are doing backfill now, we need a way to keep track of which players that we expect to be in the game after the game session starts. A reference to a map of players defined in the matchmaker data from the game session object passed to the onStart game session handler function. That's why we defined the expected players variable in our header file earlier. So in here, let's just set expected players equal to start game session state player ID to player. And now that we are expecting certain players to be in the game, we need to set a flag so that the server knows that either the onStart game session or on update game session handler functions was invoked for the reason that players are currently in the process of joining the server. So that's why we define the waiting for players to join variable in our header file as well. So set waiting for players to join equal to true. Also, like I mentioned earlier, when a game starts, because we are sticking to the 60-second max time period for a player session in the reserve state, let's call the set timer function in order to invoke the suspend backfill function to stop any active backfill request if there is one at approximately 60 seconds before the game ends. So in between these two calls to set timer, type out get world timer manager and then parentheses dot set timer, and then in parentheses pass in suspend backfill handle, comma this, comma ampersand a game lift tutorial game mode double colon suspend backfill, comma 1.0f, comma false, because we won't be calling this function on a loop, we're just going to call it once after a delay, comma, and then in parentheses float, because we're going to cast this number that we're about to pass into a float, because that number we're going to cast is going to be in parentheses as well, and that's going to be remaining game time minus 60. And then let's add a semicolon here at the end of the line. And again, the reason why it's remaining game time minus 60 is, like I just said, we are going to call this function at approximately 60 seconds before the game ends. And that should be all the code for this if start game session state.status case. Again, this is when the game session activates, and right away we are going to start our game logic through some timer functions, and we have indicated to the server that we are now waiting on players to join. So let's actually start writing the logic to deal with that. Underneath this if not game session activated statement, type out else if, and then in parentheses pass in waiting for players to join, and then a pair of squiggly brackets. And then if we are currently waiting for players to join, like I just mentioned, worst case, the players have up to 60 seconds by default from the creation of their player sessions to join the game, which usually happens right after a game session starts or a backfill request was successfully completed. Otherwise, if the players don't join in time, then their associated player session objects will change to timed out status. And at that point, if a client tries to connect to the server with a player session ID that is linked to a timed out session, then they will be rejected by the pre-login function. So let's check if we have been waiting for less than 60 seconds by typing if in parentheses time spent waiting for players to join less than 60, and then a pair of squiggly brackets. Now, if we have somehow been waiting for more than 60 seconds, then we can assume that one or more of the player sessions tied to the expected players that we are waiting on to join the game have timed out. So let's deal with this case by typing else, and then sorry about that, in squiggly brackets, type out update game session state reason, and set that equal to e update reason double colon backfill underscore timed out. Now keep in mind that I am using an enum value that was used for a reason that the on update game session handler function was called, but we can also use our custom enum for custom cases as well. And let's not forget to reset the waiting for players to join and time spent waiting for players to join variables to indicate that we are no longer waiting for players to join the game. So type out waiting for players to join equal false, and then time spent waiting for players to join equals 0. Now back up to the if statement where we haven't been waiting for at least 60 seconds, so we can't assume that the player sessions of the expected players have timed out yet. So what I want to do in this case is, because we can't assume that the sessions are timed out, we also can't assume whether or not we have any reserved player sessions, because the whole point of the code inside this else or inside this if waiting for players to join block is to wait until the game session has no more players in the reserve status, so that we can create a new backfill request if needed with the players currently in the game, because we now know we are no longer expecting new players to join. So to check whether or not this game session has reserved player sessions, we need to call the describe player sessions method, similar to how we did it in the pre-login function, but unlike the pre-login function, instead of passing a player session ID, we will be passing a game session ID as well as a player session status filter to get all the player sessions in a game session that are in reserved status. So let's get the game session ID by typing auto game session ID outcome equal AWS double colon game lift double colon server double colon get game session ID parentheses, and then we'll check if in parentheses get game session ID outcome that is success parentheses squiggly brackets, and if it is successful, then let's get the game session ID by typing out string game session ID equal f string, and then in parentheses passing game session ID outcome dot get result parentheses. And then let's make an object of type describe player sessions request, because we need to pass one to a call to describe player sessions. So write out AWS double colon game lift double colon server double colon model double colon describe player sessions request,
and then we'll call this variable describe player sessions request. And we'll set a few properties in this request. First, the game session ID, so type out describe player sessions request set game session ID, and then in parentheses pass in tchar _2 _ ANSI, and then in parentheses pass in star game session ID. And then let's also set the player session status filter that I just mentioned to only get back the player sessions in this game session that are in reserved status, because those are the ones we are going to be caring about here. So type out describe player sessions request dot set player session status filter, and in parentheses pass in quotes reserved in all caps. Can't make a mistake when typing this this word reserved here. And then let's actually call the describe player sessions method by typing auto describe player sessions outcome equal AWS :game server describe player sessions, and then in parentheses passing the describe player sessions request. And before I keep writing code inside this if game session ID outcome.isSuccess block, in the very rare case where you fail to get a game session ID, meaning that the get game session ID method call failed, then let's still consider that as time spent waiting for players to join. So underneath that if statement, type out else, and then in squiggly brackets set, or not really set, but increment the time spent waiting for players to join variable by 1. So time spent waiting for players plus plus. And then let's resume where we left off. So after calling describe player sessions, let's check if that was successful by writing if in parentheses describe player sessions outcome that is success parentheses and then a pair of squiggly brackets. And similar to what we did if the call to get game session ID wasn't successful, if the call to describe player sessions was not successful, then let's still consider that as time spent waiting for players to join. So type under here else, and then in squiggly brackets time spent waiting for players to join plus plus. And then back if the describe player sessions method call was successful, then let's get the result of that function by typing auto describe player sessions result equal describe player sessions outcome dot get result parentheses. Now before we move on, we actually have to add some code now to the GameLift server SDK, specifically in the describe player sessions result class, because like I mentioned before, we need to get the number of player sessions in this game session that are in the reserve status. However, you will not know the number of player sessions ahead of time, and the describe player sessions result class has a method called get player sessions, which is what we use in the pre-login function, and that returns a pointer to an array of player session objects. The problem is that in C/C++, you cannot deduce the number of elements in that array from a pointer to one of its elements, because a pointer to an array is essentially the address of the first element in that array. So we need a new function to get us the number of elements in that array. But don't worry, this is actually really easy, because the describe player sessions result class actually has a private member variable representing the number of elements in the player sessions array member variable in the describe player sessions result class. So all we need is a getter function. So scroll up to the pre-login function, and inside the pre-login function on the line that says, for me it's line 228, but the line that says auto player sessions equal describe player sessions result dot get player sessions, and then in parentheses we pass in some local count variable, highlight just the get player sessions method. So I just double click anywhere inside the get player sessions word, double click that to highlight it, and then right click it, and then click on go to definition, and then you're going to see two symbol results found. Now don't double click the first result, even though they both will lead to the same class, but double click the second result, or actually You may not even have to. I guess you can just single click it, but I'll double click it anyway. So the difference is that in a lot of these GameLift Server SDK header files, you're gonna see that they're split into two sections. One section is in the compiler directive if-def GameLift use std, and then the other half is if you're not using the GameLift use std macro. And that's usually because the GameLift Server SDK again splits their classes so that, you know, sometimes do you want to use the standard C++ library, or do you not want to use the standard C++ library? That's at least how I interpret it. I could be wrong, because if I scroll to the bottom of this class to the member variables of the bottom half of the class that doesn't use GameLift or doesn't use the GameLift use std macro, you'll notice that like it doesn't use the standard C++ variable types like std vector and std string. Instead, you know, it uses a char array and, you know, an object array. Although I do think, and maybe the GameLift team will look at this in the future, but maybe they should consider built-in Unreal Engine variable types like T arrays and F string, and maybe even other variable types like tmap and etc. Because these variable types do have, you know, built-in functions. Like if this was a T array instead of a player session square bracket array, then you would have built-in functions like the num function to get the number of elements in an array. But they're not using that, so again, this is what we're dealt with. And like I mentioned before, so if we scroll back up to the get player sessions method, you'll notice that it returns an object of player session pointer, and that will return the m player sessions member variable, which again is just this. So essentially, by returning this back to the user, or sorry, back to whoever calls the get player sessions function, you're just getting a pointer to the first element in the array. So you won't know exactly how many actual elements were added to that array. Yes, you have a predefined array of size max player sessions, which if you scroll all the way up, I believe it is 50 by default, I believe. Yes, you know that there's an array of 50 elements, but you don't know if all 50 of those elements are like actual values or garbage. Because if you iterate an array that, yes, has been defaulted to have 50 elements, but you don't define every single one of those 50 elements, and you iterate through all 50 elements in those array, then you will get what is called undefined behavior. Because if you don't initialize each element in an array, then they can default to some garbage values. So that's why, again, we need this player sessions count variable, because we don't know how many actual elements are in the array. So let's just type underneath this last function in the class, in the bottom half of the class, in the when you're in the not hashtag if GameLift use std section. So right before the private member variables, type out inline int, and we'll call this variable get player sessions count, parentheses, and then in squiggly brackets in the same line, since we're going to make this inline, just type out return and then m underscore player sessions underscore count. Because again, this variable will actually represent the number of player sessions in the array. Because even though, again, the player sessions, or this m player sessions array is defaulted to size 50, if we scroll up to the constructor, when we make an instance of this describe player sessions result class, that member variable is set to 0 by default. And then if I scroll down to the add player sessions array, the add player session method, you'll notice that every time you add a new player session object, the m player sessions count integer gets updated. So if you call add player session 4 times, then m player sessions count by the end of that will be 4, and then hopefully when we call get player sessions count, we'll get 4 back. And then go ahead and save your changes in this file by pressing Ctrl S or clicking on this little button up here that looks like a floppy disk. And I just want to point out one more thing while we are in this header file. If you are interested in looking at other files within the GameLift server SDK, note that by default the GameLift use SCD identifier, so up here, is normally turned off. So if you see header files split into two sections, hashtag if dev GameLift use SCD and hashtag else, then look at the bottom code half of the file that is underneath the hashtag else compiler directive. That is not grayed out. Normally in Unreal Engine it is recommended to avoid the C++ standard library, as far as I know, because the Unreal Engine standard library, which includes so many things from T arrays, F strings, and other built-in variable types to U property, U function, and other components of the UE4 reflection system, because it is so much more portable. Alright, now let's go back to the GameLift tutorial game mode C++ class. And before we go back to the handle game session update method, I just want to quickly explain, while we are in this pre-login function, why we just went ahead and got the first element in the array referred to by the pointer returned by get player sessions. Because you could argue that you don't know if there was even a value added to this player sessions array. And the reason why that I kind of just assume that is normally with the describe player sessions method, if you pass in a valid player session ID, then the method will normally not succeed. So in that case, this line, if describe player sessions outcome dot is success, would evaluate the false, and we wouldn't step inside this block of code. So generally, unless there's some bizarre scenario, if you pass in a valid player session ID, meaning there is a player session that exists that is identified by that ID, then the result returned from a call to describe player sessions will contain an array containing one player session object. If you want to be extra safe, now that we have this get player sessions count method, you can always add a check to see if there's actually one element in this array, but I am not going to do that. With all of that said, now let's go back down to the handle game session update method and continue where we left off. So after calling describe player sessions and getting the result, let's check how many player sessions are in the result that was returned by writing int count equal describe player sessions result dot get player sessions count parentheses. And if there are 0 sessions, then that should symbolize that either the beginning of the game session or the latest backfill request is quote-unquote complete in the server's eyes, because we went through the whole process of matching up players, whether it was at the beginning or in the middle of the game. And now none of the player sessions of the new players that we expect are in reserve status, meaning that we are no longer expecting new players to join. So in this case, write if in parentheses count equal 0, then in a pair of squiggly brackets set update game session state reason equal update reason colon backfill completed. And let's reset the waiting for players to join and time spent waiting for players to join member variables by writing waiting for players to join equal false, and time spent waiting for players to join equals 0. But if there are still reserved player sessions in this game session, then we are technically still waiting for new players to join. So we will just count that as time spent waiting for players. So type out underneath this if count equals 0 statement block, which I forgot a closing squiggly bracket before, sorry about that. So underneath that if statement, type out else, and then in squiggly brackets, just increment time spent waiting for players to join by 1 by using the ++ operator. And also one small change in the case where we have waited at least 60 seconds for players to join the game. So scroll down a little bit, so it should be in this very last else block here. So instead of setting update game session state.reason equal e update reason backfill timed out. I actually changed my mind. I want this to be e update reason backfill completed instead. Because I actually do want to preserve 4 of the custom values in the e update reason enum type for the for the on update game session handler function. And like I just said before, even if we end up waiting for the player sessions to time out by default, the same argument that we just applied before still applies here, whether we are waiting for new players to join from the start of the game session or in the middle from a successful backfill request. We are now no longer waiting for new players, even in this case. Alright, now moving on to the next case for this function. So if it isn't the very start of the game session or we aren't waiting for players, then let's check if our latest backfill request just succeeded by typing after this very last closing squiggly bracket before the closing squiggly bracket for the function, else if, and then in parentheses update game session state dot reason double equals e update reason double colon matchmaking data updated, and then a pair of squiggly brackets. And in here, let's do a few things. Let's clear out the latest backfill ticket ID field by typing latest backfill ticket ID equals a blank pair of double quotes, so nothing inside of them, because in this case the on update game session handler function was invoked because the current backfill request for this match succeeded, meaning we were able to match new players to this match. So as a result, there is no backfill request anymore for this match in progress, since one just finished successfully. And then let's set expected players equal to update game session state dot player ID to player, because now the players that we expect to be in the game came from the matchmaker data that we got in the game session object from the last time the on update game session function was invoked by GameLeft. And lastly, we should be waiting for players to join now, because that matchmaker data should have newly matched players. So type out waiting for players to join and set that equal to true. So the next time this handle game session update function gets called, it will start executing the if waiting for players to join block of code above that we just wrote. And I just want to note, in case I did not note it earlier, that after this, if we go back up, after this if start game session state dot status if block is executed, the next time the handle game session update method is called, it will go into the else if waiting for players to join block of code, similarly to, once again, if a backfill request succeeds and we go into this else if block of code, the next time the handle game session update method gets called, it will also go up into this else if waiting for players to join block of code. Now let's move on to the last case for this function, which is when a backfill request is not in progress because 1, it failed, or 2, we just finished waiting for players to join the game. So underneath this else if block, type out else if, and then in parentheses pass in update game session state dot reason double equals e update reason double colon backfill canceled, and then double pipes to signify the logical or operator, or update game session state dot reason double equals e update reason double colon completed. And then on the next line, to make this a little more readable, double pipe again, so or update game session state dot reason equals e update reason double colon backfill underscore failed, and then finally one last double pipe, so or update game session state dot reason double equals e update reason double colon backfill underscore timed out, and then a pair of opening and closing squiggly brackets. Now let's move on, so if update game session state dot reason equals any of these e update reason enum values, then we know that there is no backfill request going on currently, because 1, either the on update game session
Handler function was invoked for a reason that the backfill request did not succeed for one of three reasons, including backfill canceled, backfill failed, and backfill timed out. Or there is no backfill request going on because we just finished waiting for players to join the match, hence the customly made backfill completed state. So because we know there is currently no backfill request going on, let's go ahead and clear the latest backfill ticket ID member variable by writing latest backfill ticket ID equals a blank string, which is just a pair of double quotes with nothing inside of them. And I also want to point out, in this tutorial, the server will not make a backfill request when one is currently going on, and that is exactly what this else if block of code is for, initiating a new backfill request if needed. And to do that, we first get all the player objects from the expected players map associated with the players that are currently in the game. And the expected players map will either point to the start game session state or the update game session state player map, and whichever one of those maps is used, because remember that when handle game session state is called, it can reach this block of code without successfully completing a backfill request. So in that case, expected players would point to the player map in the start game session state. But once there are completed backfill requests, successfully completed backfill requests for this match, expected players will point to the player map in the update game session state, because as we iterate through the players who are currently in the game, we get the associated player object from the expected players map, and theoretically there should not be a player in the server that is not a part of the latest matchmaker data associated with this game session, according to our logic. So let's get all the player states in the game currently by writing t array and then in carets a player state star and then player states, and then set that equal to get world and then parentheses arrow get game state parentheses arrow player array. And then let's make a local tmap variable for the players that could potentially be in a new backfill request that are currently in the match right now. So type out tmap, and then in carets the keys in this map will be of type f string, and the values will be of type aws :gameleft :server :model :player, and the variable will be called connected players. And let's iterate through all the player states currently in the game by typing for and then in parentheses a player state pointer player state player states and then a pair of squiggly brackets. And just to be safe, let's do a null pointer check on the player state that we're currently iterating on by writing if in parentheses player state not equal null ptr and then a pair of squiggly brackets. And then let's cast the player state pointer to a GameLift tutorial player state pointer by typing a GameLift tutorial player state pointer GameLift tutorial player state, and set that equal to cast and then in carets a GameLift tutorial player state, and then in parentheses pass in the player state to this function. And let's do another null pointer check on that by typing if in parentheses GameLift tutorial player state not equal null ptr and then a pair of squiggly brackets. Then let's use the player states matchmaking player ID to look up the associated AWS GameLift server model player object in the expected players map. So type out auto player obj equals expected players dot find, and then in parentheses pass in GameLift tutorial player state arrow matchmaking player ID. Then let's check if that's a null pointer by writing if in parentheses player obj not equal null ptr and then in squiggly brackets. If it isn't, then let's add that player object to the connected players map that could potentially be passed to a call to create backfill request by typing connected players dot add, and then in parentheses with a key, passing game lift tutorial player state, arrow matchmaking player ID, and then for the value, pass in star player obj. Now let's check if we quote-unquote need to make a backfill request, meaning that there are currently less than 4 players connected to the server, but before we do that, let's check if the game is empty, meaning no one's connected to the server. So at this point, there are no current backfill requests going on. We are now waiting for players to join, so we could make a backfill request for this match, but for this tutorial, if it does come to that point where there are now no players in the match, once we've reached this else if block of code, then let's just end the game. So after this for loop, type out if in parentheses connected players dot num parentheses equals 0, and then in squiggly brackets just call the end game function. However, if there are players connected to the server at this point but there are less than 4, then let's make a new backfill request for this match, because the max amount of players that matches in our rule set can contain is 4. So there's no point in making a backfill request in the case that there are 4 players in the match. So type out underneath this if statement, else if in parentheses connected players dot num parentheses less than 4, and then a pair of opening and closing squiggly brackets. So let's get the game session ID by calling get game session ID. So type out auto game session ID outcome equals AWS double colon game lift double colon server double colon get game session ID parentheses, and check if that function call succeeded by typing if in parentheses game session ID outcome that is success parentheses, and then add another pair of squiggly brackets, and in here let's actually get the game session ID by writing f string game session ID equals f string, and then in parentheses passing game session ID outcome dot get result parentheses. And then let's get the matchmaking configuration ARN by typing f string matchmaking configuration ARN equals start game session state dot matchmaking configuration ARN. And then let's call create backfill request and set our latest backfill ticket ID member variable to the return result by typing the latest backfill ticket ID equals create backfill request, and then in parentheses pass in the game session ID, the matchmaking configuration ARN, as well as the connected players. Now we will know if the backfill request was created successfully if the length of the ticket ID return is greater than 0. So type out if in parentheses latest backfill ticket ID dot len parentheses greater than 0, and then in squiggly brackets so that if we know that there's currently a backfill request going on, then let's set the update game session state reason member variable. So type out game session state dot reason, and we'll set it equal to e update reason double colon backfill underscore initiated, so that the next time this handle game session state function is called, the outermost else if block of code that this code that we just wrote was contained in won't be reached. In fact, none of the outermost if else if conditions will evaluate to true until the on update game session handler function is invoked. But at that point, the backfill request will be finished, so we will either be waiting for new players again in the case of success, or back in the else if block of code in the case of failure. Also notice that in this outer else if block that we are in, that we don't have many else statements. That's because if something goes wrong when we are in here, the next time the handle game session update function gets called, we will just end up back in here. And to finally finish this function, let's wrap all the code inside with the hashtag if with underscore game lift and hashtag and if compiler directives. And then before we compile this project again in the development server configuration for the Win64 solution platform, I just want to talk about a few things that maybe some people were wondering about. So even though we decided to end the game if we found no players in the server right after a backfill request finishes, the server can still have at one point no one in the game. For example, if you start a backfill request and while waiting for the backfill request to finish, the current players in the game just leave, but that backfill request will still be out there in our tutorial because that's how we wrote the logic to handle that. And the request could still successfully be fulfilled and up to 2 new players could join the match. Also, while waiting for players, maybe we get really unlucky. For instance, at the start of a game session and no one joins the game, then we wait until the player sessions time out and then we end the game. And that leads to my the next thing that I want to address. So as for why I decided to make a time spent waiting for players to join variable is that although it seems redundant in the sense that there will always be a point where the game session has no reserved player sessions using this tutorial's logic, I wanted to include the logic to check for the time spent waiting for players to join because 60 seconds by default is quite a bit of time and accidents or slow connection speed may occur. So you could, if you wanted to, change this value from comparing it to 60 to something lower. For example, like 30 or 40. But then if you did that, then in this else block down here, I would recommend in addition to what we already do, which is setting update game session state.reason equal to update reason backfill completed, as well as resetting a couple of member variables. You should find any player sessions in the match in reserve status still, because after, let's say, 30 seconds of waiting for players to join, that is still technically a possibility. There could be reserved player sessions. So you would want to call the describe player sessions method again with a game session ID and a reserved player session status filter, exactly like how we did it above here. And then just call terminate player session on all of those player session IDs of player sessions in reserved status. And lastly, let's just scroll up to the init new player function really quickly, because because some of you guys might be wondering why didn't we use the expected players member variable here or here, basically, instead of update game session state.player ID to player and start game session state.player ID to player. And the reason is because we set expected players in the handle game session update function that runs every second, but the on start game session or on update game session handler functions could be invoked by game lift and players end up joining the match right away, and hence this init new player function gets invoked before the handle game session update function gets called. So we have to check the start game session state and update game session state member variables in this function just to be safe. But the reason why I decided to make an expected players member variable at all then is that in the handle game session update method, it saves us a little code to write. So instead of checking whether to use the update game session state or start game session state player map, I just defer to this expected players variable instead. With all that said, let's go ahead and compile our project again. Make sure you have development server selected for the solution configuration up here, Win64 for the solution platform, and then right click your project in the solution explorer and select build. And actually, I forgot that we have to add some more code to deal with one more scenario. That scenario is when a player leaves a match and there's currently a backfill request. So in this case, we should stop that backfill request so that the next time the handle game session update method gets called, the update game session state.reason should be backfill canceled. And then once that happens, then hopefully the backfill request gets replaced with a new backfill request, because the original backfill request most likely had the player that just left. So we should immediately stop that backfill request, because when that player who just left starts a new matchmaking request, the backfill request that currently is in process will get canceled, because in game lift there can't be more than one active matchmaker request with the same player ID in their array of players. And ultimately, the older ticket gets canceled in this case, and the newer matchmaking request continues. And the weird thing about this, and I think maybe the game lift team should look at this if possible, is that in this case that I just mentioned, where if there are multiple tickets in circulation with matchmaking with the same player ID, and then the older ticket gets canceled, is that unlike when you call stop match backfill through the server SDK, when a backfill request gets canceled this way, the onUpdate game session handler function does not get invoked. So keep that in mind. The onUpdate game session handler function does not get invoked for when matchmaking requests get canceled. When backfill requests get canceled due to the existence of a newer matchmaking request with a player ID that the backfill request had. So hope that makes sense. So I want to scroll up to the suspend backfill function, or sorry, I want to scroll down, I guess, to the suspend backfill function, because we have a lot of logic to stop backfill in there. So I'm just gonna copy everything inside this hashtag if with game lift and hashtag and if compiler directive, and then I'm gonna scroll to the logout function, because remember that the logout function gets called every time a player leaves the match. So I think what we should do is in here, so I think before we remove the player session, I think we should stop the backfill request. So I'm going to press enter inside this hashtag if with underscore game lift hashtag and if compiler directives, and I'm just going to paste that code, but we're going to make a few changes here. So let me just fix some formatting right here. But so a couple things here. Unlike suspend backfill, we won't try to stop the backfill request in multiple attempts, so we'll only do it in one attempt, right? So if something goes wrong while trying to while calling stop backfill request, then we won't try again like after 1 second. So let's get rid of the this else block here that calls set timer on the suspend backfill function. So get rid of that, and also this if statement here, so if not stop backfill request. I don't want to get rid of it completely. I do want to get rid of what's in the body currently. So again, I don't want to call set timer. Let me get rid of these opening and closing squiggly brackets, and let me get rid of the if statement, including the parentheses, and then let me get rid of this exclamation point, and then at the end I'm going to add a semicolon. So literally all this is going to be is if a backfill ticket currently exists while a player is leaving the match, then we'll try to get the game session ID, matchmaking configuration ARN, and we'll just call stop backfill request on that ticket ID that we currently have stored in the game mode class, and hopefully that will lead to the cancellation of the backfill request. Alright, and in addition to this, this is actually very last minute, so I apologize for the change that we're about to do, but go to the Lambda dashboard in your web browser of choice, specifically the function section, and we're not making a new function, don't worry, but we have to modify an existing function. So in my case, I have a function called track events. That's what I named it in an earlier part of the tutorial, but basically this should be the Lambda function that's currently subscribed to the SNS topic that is set as the notification target for flex match notifications in your matchmaker configuration settings. So let's scroll down here, and inside this inline code editor, let's press Ctrl+A a few times. So why am I in here making this completely last minute change? So in the absolute edge case where there's a backfill request involving player sessions in the completed or timed out state, and this may even apply, and yeah, I believe that will be the case, and maybe this applies to player sessions in the reserve state, but I can only confirm for when there's a backfill request with player sessions in the timed out or completed state, and that backfill request still gets filled. So let's say we have 3 players, and then or sorry, let's say we have 4 players in a match, 1 player leaves, so a new backflow request gets made with those 3 remaining players, and then another player leaves. But let's say, even though we just coded logic to cancel the current backflow request, and hopefully next time handle game session update method gets called, a new backflow request will be made with the remaining players. The issue though is that what if in the rare case, what if we fail to stop that matchmaking request? So ultimately there's still a backflow request for 3 players even though there's currently 2. So one of those player sessions is in completed status now. So what ultimately happens is when a message is sent to FlexMatch, when FlexMatch sends a message to the SNS topic that ultimately gets relayed to this track events function that is subscribed to the topic. When we iterate through the tickets in that message, right? When we iterate through the tickets in that message of type matchmaking succeeded, because ultimately, let's say that backflow request gets fulfilled, the backflow request containing 3 players, even though there's in actuality 2 players in the game. What ultimately happens is when you iterate through all the players in that backfill ticket, it will still contain that player whose session is currently not active. It will contain it. The problem is it will no longer contain a player session, the problem is that the player will no longer contain a player session ID. And ultimately, right now what goes on is you'll have this player item here, and you're setting this player session ID attribute equal to the value of a property that doesn't exist. So player.player session ID in this very, very extreme edge case will be null. It'll be blank, and as a result, when we call DynamoDB batch write item, you'll get an error because you can't have any attributes in the items that you're writing to a table in DynamoDB be blank. It just won't happen. So we have to do an if check. It's ironic because I added a lot of if checks throughout this tutorial, but this is actually the one time where you kind of need an if check to deal with a kind of rare situation. So let's just write out in the line above where we set player item.m.player session ID equal to squiggly brackets s:\player.player session ID. Let's just write if in parentheses, and then all we're going to do is player.player session ID. Just going to check, okay, is this a valid value? And then type out a pair of squiggly brackets, and then the line where we set player session ID in the player item, just cut that line, so Control X, and paste that inside that if statement we just made. And that is pretty much it. That should handle that edge case I was just talking about. So now when FlexMatch sends an event message to our notification SNS target, the message will still be exactly the same. It's just that we won't get an error when writing items to the matchmaking tickets table in DynamoDB. So go ahead and click the save button to save your changes. And don't worry if you're paranoid, even though this is just a really small change. The Lambda code inside the GitHub repository linked in the description below will have everything, the most up-to-date Lambda code. So just trust in the code in the GitHub repository. And also, this won't affect our functionality from before, because we're not really doing anything different, right? We're just checking if the player session ID exists, because normally we do get player session ID values in almost all the players involved in all the tickets involved in ticket of messages of type matchmaking succeeded. But in the case of backfill, we can no longer assume that this player session ID and all the player objects will necessarily be populated. And with that said, let's go back to Visual Studio and build our project once again for the development server configuration for the Win64 platform. So right-click your project in Solution Explorer and select Build. And once your project is finished compiling, before we package the server again, let's go to the project directory in File Explorer. So because we made some slight modifications to the GameLift Server SDK plugin, we have to go ahead and delete the GameLift Server SDK folder in the original or in the last server build, because we want that server SDK to get regenerated when we package the project. So go to the folder where your package server build was, or the old one is. So mine is in a folder called Windows Server, so I'm just gonna go to the Windows Server folder, and then the plugin should be located in the folder named after your project. So in my case it's called Game Lift Tutorial, and then let's take this plugins folder and just go ahead and delete it. Alright, now let's go back to the Unreal Engine editor so that we can repackage our server. So go to File on the top left corner of the page and go to Package Project, and make sure for the build target that you have Game Lift Tutorial server selected. So right now if you have Game Lift Tutorial selected, then just go ahead and select Game Lift Tutorial server, and then go back to File, and then go to Package Project again. Make sure for the build configuration, in this tutorial I'm going to have development selected, and then once you have the configuration checked as well as the target, go to Windows and then select Windows 64-bit, and then for the folder for where you want to package the project to, I'm just going to stick with the default project directory. So once you have a folder selected, just click on Select Folder, and then on the bottom right here, click on the Show Output Log so that you can see the packaging logs. And after the server has finished packaging, I just want to show quickly in File Explorer, in that window we were just in, that the plugins folder was indeed rebuilt and remade, and inside of here we once again have the Game Lift Server SDK. Now that the Windows Server has finished packaging, I do want to point out, because we only made changes in the Game Lift Server SDK and in the game mode class, specifically the Game Lift Tutorial game mode class, since the last time we packaged our project, we should not have to repackage the client, because the changes we made to the project should have only affected the server, not the client. So with that said, let's go ahead and upload our new server build to GameLift. So let's open up command prompt. Make sure that once this is open that your AWS CLI is configured before calling any AWS CLI function. So to upload the build to GameLift, type out AWS GameLift upload-build. That's the name of the command, and then this command will take in some parameters. So the first one will be --name, and in this tutorial I've just named the builds after the project. So in my case it will be GameLift Tutorial, and then the next parameter will be --build and --version. This is how we differentiate between multiple server builds of the same project. So the last server build, the version was 1.0.1, so for this one I'm going to use 1.0.2, and then the next parameter will be --build-root, and then the value for this parameter will be the path to the directory containing your server build. So I'm going to pass for this parameter the value in quotes, in double quotes, because the path for my server build directory has a space in it. So the path is going to be in quotes users/users/documents/unreal-projects/GameLift-tutorial/Windows server. And then the next parameter is going to be --operating system, and this will be, the value for this will be Windows_2012, since this is a Windows server build. And then the last parameter that we're going to pass to this function is --region, and the value for this will be the code of the region that you're operating in. So for me it's US-East-1, and don't worry, we will have this command in the description below. So once you have this all written out, just go ahead and run the AWS GameLift upload build command with these parameters by pressing enter. Once the new server build has been uploaded to GameLift, let's go to the GameLift dashboard in the web browser of your choice, and once you're on the GameLift dashboard, you should see your new fleet here under where it says builds in this list of builds. So let's go ahead and create a new fleet for this build. So to do that, click on the name of the build. So I know this is the last build I uploaded because the version is 1.0.2, so just click on the name of the build, and then from here click on actions, and then select the create fleet from build option. And as for the name of the fleet, let's go ahead and follow that naming convention that we used for the last fleet that we made. So starting with the name of the build, in our case it's Game of Tutorial, which is also the name of the project, space the instance type used for this fleet, and since we're sticking with the free tier, the instance type will be c5.large, so let's type out c5.large, space the operating system of this of the server processes in this, or the operating system of the instances in this fleet, so that's going to be Windows, and then the fleet type, which is going to be Spot, and then the word fleet, and then the build version. So in our case it's 1.0.2, and like I just mentioned, this will be a Spot fleet, so by where it says fleet type, go ahead and change it from on-demand to Spot. And the reason we're using Spot fleets again is that Spot fleets are significantly cheaper than on-demand fleets. Now let's scroll down to the process management section, specifically under where it says server process allocation. And in here, this is where we are going to define the server processes that will run on each EC2 instance in our fleet. So for the launch path, this will basically be the path to the server executable relative to our Windows server folder, or wherever folder your package server build was packaged to. So for this, I like to go to File Explorer, specifically where our project directory is located, specifically the Windows server folder, and then from here go to the server executable, not this one, but the one in the binaries folder in this directory. So go to the folder named after your project, in my case it's Game of Tutorial, then the binaries folder, then the Win64 folder, and then in File Explorer here at the top, in this little text box, that contains the path of the directory that you're currently located in. Copy everything up to but not including the path of the Windows server directory, or wherever your server build is packaged to. So copy this part, the Game of Tutorial /binary /Win64, paste it in here in the launch path, because this is where the server executable is located, and then type out / and then the name of the server executable with the file extension. So gamelift tutorial server.exe. Make sure you have the full name of the executable, including the .exe extension. And then for the launch parameters, it's going to be the exact same thing as the parameters in the server process in the last fleet. So -port equals 7777, because we are explicitly defining which port that the server process will run on. And then the next parameter will be -password equal dummy, because we need to be able to pass the lambda authorizer when at the end of the game, if the server process reaches the end of the game logic, then it's going to call the record match result API method, and it needs to pass in the right value for the lambda authorizer in order to invoke the lambda function. And then for the number of concurrent processes, keep this at 1, because in this tutorial we want to only run one server process on a specific port at a time. And then click on the green check mark on the right of this row inside this table to save your changes. And unlike the last fleet we made, let's add a few more server processes for this instance. So let's click the add configuration button 4 more times to add 4 more server processes, and the launch path for each of these server processes will be the exact same one as the first process that we defined, or it will be the exact same path as that of the first server process we defined. So just Control C, copy that value, and just paste that into these text boxes. And for the launch parameters, it's going to be exactly the same again as the first server processes launch parameters. So type out -port equal, but this time it won't be 7777, because remember I just said we don't want to run multiple processes on a specific port at a time. So type out 7778 to make sure that the value is different from the port parameter of the other server processes, but the password will still be the same. So type out -password equal dummy. And then let's just copy this value to make it easier and just paste it in the rest of these server processes launch parameters values. And concurrent processes, again, keep that at 1, because like I just said, we only want one server process running on one port at a time. But then for these bottom 3 server processes, let's change the port parameter value for each of them to something unique within these server processes, these 5 server processes. So notice how I'm changing them to a unique value, preferably within a contiguous range. It'll just make it easier for when we open up these ports later down in the fleet details. And then once you're done with that, just click on these green check marks on the right side to save those changes. And like I just said, we actually have to open these ports now that these server processes are listing on for incoming player connections. So scroll down to where it says EC2 port settings, and then click on the button underneath the table that says add port settings. And then for the port range, so specify the range of ports that we are using again for the server processes. So in our case, it's going to be 7777-7781. And basically what this means is that all ports within this range, inclusive of both the start and end range, will be used for this setting. So let's change the protocol from TCP to UDP, and for the IP address range, type out 0.0.0.0/0 to indicate that we are allowing anyone to try to connect to anything running on these ports. So click on the green check mark to save your changes. And as for the protection policy, remember again in this tutorial, keep the protection policy at its default value of no protection. And then once you have all that done, go ahead and create the fleet by clicking on the initialize fleet button. And once the fleet is created, we now have to wait for the fleet to enter the active status. So go to the events tab and periodically just go ahead and click on the refresh button to see when we get an event of code fleet scaling active, I believe. I could be wrong about that, but doesn't matter. The activation process of a fleet takes approximately 20 minutes anyway, so go ahead and pause the video and come back in roughly that time. Okay, now that this fleet is active, and just to confirm, you can always click on the refresh button to see if the latest event is of type code fleet scaling event, and then of course refresh the page because this UI is not reactive or reflective, so the status won't change to active if the fleet is actually active. But at this point, one more thing we have to do before testing out the server by running 4 clients. We have to change the fleet destination in our queue associated with our matchmaker to point to this new fleet that we just made. So click on where it says fleets and then go to where it says queues, and then from here click on the name of our queue, and then from here click on the actions button and then select the edit queue option, and then from here under where it says destinations, you'll see a table with a bunch of fleets or aliases. Well, in our case we only have one fleet because that's just what we're doing in our tutorial. So in the only row in this table, just click on the pencil icon on the right to edit this fleet destination, and then under where it says fleet or alias name, just go ahead and click on this drop down menu and select the new fleet that we just made. And it should be easy to find because to the right of all of these fleet IDs, you should see in parentheses the name of the fleet. So the last fleet we just made was Game Loop Tutorial C5.large Windows Spot Fleet 1.0.2. So go ahead and click on that. And then to save your changes, just go ahead and click on the green check mark button and then click on the submit button. Okay, now let's go ahead and finally test our server, the moment of truth, to see if the backfill that we just implemented works. So go to File Explorer, specifically where your project is located, and let's run the client that we actually used for the last fleet, because like I just said earlier, all the code that we mentioned since the last build was all server related, so stuff in the game mode class as well as in the Game Loop server SDK. So go to where your last client build was packaged to. So in my case, it was in a folder called Windows No Editor. And then in here, I'm not going to double click the application to open it up right away because it's still going to use these size parameters from last time. And with those size parameters, we can only fit in 2 clients on the window at once. And I want to try to fit in 4 on the window at once to give you guys a better idea of what's going on. So let's in File Explorer, in this text box, that has the path of the directory that we're currently in. Just replace the text inside with gamelift tutorial.exe, so the name of the application including the file extension, and then space res x, and we'll set this equal to 500, and then res y, we'll also set that to 500, and then we'll pass in 2 parameters in addition to those res x and res y values. So for win x, we'll set that equal to 500 as well, and lastly for win y, we'll also set that to 500, and then just press enter. So what that's going to do is it's going to launch our client in a window of approximately 500 by 500. Now just a warning, you may have to adjust those parameter values that I just set in that command, and also don't worry, that command will be in the description below as well. But I am on a 1920 by 1080p monitor and Windows resolution, so that's why those parameters will work for me when trying to fit in 4 of these little windows on the same screen. But just to note, go ahead and close this window. So I don't know if I mentioned this last time, but those parameters will only be remembered by, I guess, Windows when you run this application the next time, only after closing a window of that size. So you have the application running 500 by 500 Windows size, then you close it, then the next time you open it, all the future clients that you open up will also be of size 500 by 500, unless you of course change the size parameters and then close it again. So let's double click this now 4 times so that we can get 4 clients. So again, I'm just going to launch the gamelift tutorial client executable about approximately 4 times, and it's going to be kind of weird to fit all of these on the screen at once, but I'm going to try my best. So, and let's just launch the executable one more time, and let's try to fit this on the screen as well. And let me just minimize this browser window as well as our running instance of Visual Studio, so that, and maybe Unreal Engine as well if you're running that, so that you guys can better see what's going on. So just a note, since the last time I tested the client and server together, I made 2 new accounts because now I want to test 4 clients at once. So I did that off screen. So if you guys only have 2 accounts, go ahead and of course just sign up. You can also sign up in one of these client windows directly, and then that will also work. That'll automatically sign you in, and then you'll be able to join a game right after signing up. Or of course you can make a new account by using Google Sign as well, but I'm just gonna go ahead and log into my 4 accounts. So I'm just gonna log into my floperam account first, and then I have, of course, maybe I mistyped my password. That tends to happen with me sometimes. So okay, there we go. And then again, I have 1 account that I use to make with Google Sign In, so let me do that real quick. So again, let me go into that account, and then in my next account, it's just a random account I made, so I'm going to sign in with that, and then for my last account, let's sign into that as well. Okay, what we are going to do first is we are going to try to get 2 clients in a match first, and then hopefully we can backfill that match with the other 2 clients. So these 2 clients on the left here, I'm going to click the join game button on both those clients, so that it'll start a matchmaking request on each client, and then hopefully these 2 players can get into a match. Also, just a note, while you're in the main menu map, you can always click or double click to lose focus and move to another window. But when you're in one of these when you're in one of these game windows, you have to alt tab to switch between the windows. Alright, we have 2 players in a match. Let's go back to the clients that haven't joined the game yet, and let's press join game on both of these clients so that we can try to get these guys to backfill the remaining match. And wow, that was really quick. So seems that the backfill request was indeed successful. So we were able to get we were able to get both of those players into the exact same match. Let's say I actually leave now with this player. So I'm going to press escape. So as you can see on pretty much almost all of those clients, and that that player just left. So we should have a backfill request going on now with 3 players, the 3 players still in the match. So if I click join game on this client that just left, we should be able to get right back into the match. So that makes absolute sense. Now let me go to the 2 clients, 2 other clients, and what I'm going to try to do is I'm actually going to quit out of 2 clients this time. So let's press escape again, and then let's go to maybe this guy here. I'm going to press escape on that guy, and there's now 2 players in the match. Let's see if our logic works here. So if we try to start a new matchmaking request on both of these clients that currently aren't in a game, so let me just click join game on both those clients, we should be able to get back into the match, and that is indeed the case. So that looks pretty good here. I'm going to do something really crazy now. I'm going to have 3 players leave the game now. So I'm going to escape out of this guy. Let me go to another client. Let me escape out of this guy. This guy, let me escape out of him too. So now we have 1 player in the match. So the question is, can this one player in this match get backfilled with 3 new players? Now let's do it. If you want to backfill with all 3 of those players, you gotta click the join game button really fast. So let me click on all 3 of those clients. So let me just click join game on all of these guys really fast. Oh, see, I didn't do it fast enough. Because I didn't do it fast enough, you'll notice that so what happened here was actually 2 backfill requests were made and completed very quickly. So in that case, I wasn't able to do it, but you could theoretically have gotten 3 players to rejoin this match. But what we instead did was, first we did 1 backfill request to get 1 player in the match first, and then ultimately we created a new backfill request to get the 2 other players into this match. So now we have 4 players again, and also we're approaching that 60 seconds until the game is over mark. So at this point, suspend backfill should be called, so there's going to be no chance of a backfill request for this match. So let's say I leave the client, let me make the client leave the game on this end, right? And if I try to join back the game, try to backfill that game, it's not going to be possible, right? Because there's no backfill request going on anymore. Once 60 seconds until the game is over is reached, not only are current backfill requests canceled if one exists, but also the handle game session update timer handle gets cleared. So for example, if I press escape here and if I click join game on this client, these 2 clients now are going to get into their own match and not going to be able to backfill that match. So as you can see, those 2 clients were indeed able to get into their own match. So I find that quite interesting, and let's actually just quit out these 2 clients in this new game session, because I want to go actually to the game lift dashboard as well as the DynamoDB dashboard, and maybe even look at some CloudWatch logs to kind of explain the flow of exactly what happened. So we saw the Cowboys lost and the Aliens won, and this guy's player stats got reflected, and this client's player stats got updated too. And believe it or not, even though these 2 client windows, even though their player stats weren't updated yet, because we would have to reload the main menu widget to do so, since we're not periodically calling get player data in these 2 windows, but we're gonna actually see in the DynamoDB table that actually, believe it or not, most likely these 2 guys' player stats actually got updated, and I'll explain that why. So let's go to the web browser of your choice and make sure you have the game lift dashboard, the DynamoDB dashboard, as well as the CloudWatch dashboard open. Well, let's start with the game lift dashboard, specifically the fleets page. So if you're still on the queues page, just click on where it says queues and then go to where it says fleets. And then from here, just select the new fleet that you just made. And then from here, go to the game sessions tab and ignore this bottommost game session that was made and terminated. This was just for me testing just off screen. So let's focus on these 2 game sessions above that one, because these are the 2 game sessions that we just saw that when I was testing the game. So if you notice that the latest game session only lasted 16 seconds, it was really short, right? Because if you remember, I was testing whether or not we could backfill a match when there was less than 60 seconds remaining in the match. The answer was no, right? So when I got those 2 players, those 2 clients who were in a match to start a matchmaking request, they got into their own match, which is normal because that other game session couldn't be backfilled. and then I left right away with those 2 players. That's why this game session only lasted 16 seconds. Now, if we click on it, you'll notice that there's only 2 player sessions in it, because there were only 2 players in that game at one moment in time. So let's go back and let's actually go to that other player session, because if we click on this one, you're gonna notice a lot more player sessions. But you might be wondering, how is this possible, right? Because there were only 4 players in the match at one point in time max, and they were the same 4 players, right? But that's the key, right? So you still make a unique player session object for when a player rejoins a game, or joins a game in general. Notice, like, you see all these player ID values here. It's kind of hard to tell, but these are all, like, if you took all of these player ID values, there wouldn't be more than 4 player IDs. And I'm trying to scroll down here, but so even though there are multiple player sessions, in the end, if we look at the list of player IDs, there were still only at most 4 players. So I just wanted to sort the player ID by clicking on this, so that's kind of better to see that there are 4 unique player IDs here. I know it's kind of hard to see, maybe just to expand this section a little bit so it's a little easier to see, but I just want to make that note for anyone who may be confused. Hey, why are there a bunch of player sessions when there were only 4 players in this match? That's because it's player sessions, not players. So players are going to be identified by player IDs, but their session, their time in the game, will be identified by the actual session. Hence why, if you notice, the total time for a lot of these player sessions didn't last the whole extent of the game. In fact, only one of these players, I believe, I never quit out of the game, and that's why the total time for one of these game sessions, for one of these player sessions, took up the entire length of the game session. And notice how this is the only player session object for this specific player ID. Okay, now let's go to the DynamoDB dashboard, specifically the table section, and let's start with the player section, and specifically in the items tab, so that we can see all the items in this table. So I currently have 4 players, right, just to make it easier for testing. And as you notice, you'll notice right away that for 2 of these players, the number of wins and losses, if I minimize this browser window, don't correspond with the wins and losses for 2 of these clients, specifically this guy and this guy. So this client was on the losing team clearly in that last game, or in the second to last game session that was made, and this guy was on the winning team on that second to last game session. Because if we go back to DynamoDB, we have a guy with 12 losses and 10 wins, whereas what you saw in the main menu map of one of those clients was that he had 11 losses and 10 wins. And then we also had a guy with 15 losses and 6 wins on that client, but on here in DynamoDB, that guy actually has 7 wins. And again, we're not seeing the changes because those clients who just left the game, or who ended up leaving that game session towards the end of the game session, I think maybe around like 40 or 30 seconds before the game ended. Those players, even though they ended up joining another game, they left that game in time before the pick a winning team handler function wasn't, or timer function was invoked. Remember, pick a winning team, so a winning team will only be chosen if the game actually goes its full duration. And the only way a game will go its full duration is if at one point there isn't 0 players currently in the game before there are 60 or less seconds left in the game. So that's why we don't see that's why, so if I go to the match results table, right, for example, so I know there's going to be a lot of entries here. I'm going to be the first to admit, so I did a lot of testing off tutorial, but let me just look at the latest entry here, because I believe these entries are sorted by default by when they were inserted in, I guess, descending time order. So I'm going to look at this latest entry here. So if we look at the losing team, it was aliens, and if we look at the winning team, it was Cowboys. So I do remember that does seem to be right. And also, luckily, we have the game session ID, right? So if we just look at the game session ID, we'll look at these last few values, AC12B, and then we'll go back to the game dashboard. And okay, so this is not the match result for this specific game session. So we actually have to keep looking. Let me look. So it's gonna be tough, so I'm gonna have to find this. I believe I can add a filter, so I can do game session ID, right? Game session ID, or sorry, no, it's not even game session ID. The attribute is called filter, and let me just get the game session ID from the game dashboard, and then just paste it here, and then we'll do the start search. Okay, so we have the entry, and also just to confirm that there wasn't a game session, that there wasn't a match recorded for that one match that literally lasted 16 seconds. Let me just do a search on this in DynamoDB just to show that there was no match result recorded for that game session. So let's go back to the game session that actually lasted the full duration of a game session. So let me get that game session ID, and let me go back to DynamoDB and just paste that value in there, click on start search. Okay, so let's see the match result that was recorded in DynamoDB. So let me click on this item in the table from the search results. Let's look at the losing team and winning team. So the winning team was actually Aliens, and the losing team was Cowboys. And if memory does serve me correct, if you go back in the video, I believe that was the case. Again, so Aliens team had 2 players, Cowboys team also had 2 players. Now you may be confused because by the time the game ended, and by the time on the screen for the players who were still in the game, when it said the Cowboys lost and the Aliens won, two of these players here weren't in the game. So why is it that they were still included in the match result recorded to DynamoDB? The reason is that these players from these teams rely on the latest matchmaker data from the game session object. Now, the matchmaker data in a game session only gets updated in 2 cases. Either one, the game session just started, so match was just made, and hopefully it gets hosted on a game session, and then that game session will, as a result, have that matchmaker data. So the players who are originally supposed to be in the game at the very start. Then the matchmaker data will change every time a backfill request gets fulfilled successfully. So if you have a backfill request and you're able to find other players to pair up with that backfill request to successfully update that match with new players. So essentially the last time a backfill request was completed for that second to last game session that lasted its whole 4-minute duration, it was backfilled with a total of 4 players. So in the end, after that backfill request succeeded, there was 4 players that were supposed to be in that match. So as a result, that was the latest matchmaker data, because after that point, backfill requests were suspended by the suspend backfill function, and then the handle game session update function was also stopped so that a new backfill request couldn't be made. So ultimately, by the end of the game, these 4 players were the players in the latest matchmaker data for that game session, and hence why they were all included in the match result recorded to DynamoDB, because this Lambda function relies on the game session data returned by the describe game sessions method. And I know that I said earlier that I wanted you guys to open up the CloudWatch dashboard so that we can look at the logs for the track events Lambda function. This is the function that is subscribed to the SNS notification target for our matchmaker. So when events with regards to matchmaking requests get sent by FlexMatch to our notification target, our Lambda function gets invoked. And since we had that log message, our console log statement in there, we also print out logs, specifically the actual message sent by FlexMatch/GameLift. Now, again, I know I said we were going to trace the logs, but I I was just doing that just now. I was trying to record me tracing the logs, and it was getting a little too complicated, and I didn't think it was going to be easy to follow. So I decided not to trace the logs with you guys in this tutorial, but I definitely encourage you guys to do it on your own, because it is kind of interesting trying to piece together what exactly happened. But also keep in mind when you are looking at these logs that they might not be in order. That's one. And two, this is very, very rare, but I have seen it happen. Sometimes logs might be missing. So again, just keep those few things in mind when looking at these CloudWatch logs. Okay, now let's minimize this browser window and let's go ahead and test our clients, because I want to test one more case. So first, I know you guys haven't seen it in this tutorial series so far, but it is possible to get 4 players in a match within like first try, I guess we can call it. Like basically you can have 4 players get paired up in a match all at once. So starting from individual requests. So if I click join game on each of these clients really quickly, there is a chance that they will all end up in the same match together at the start of a game session. So let's try to do that. Click these buttons really fast. Okay, so took a while, but they're all looking for a match now, and hopefully, if we're lucky, if our rule set allows for it, they'll get into a match. Okay, so we weren't that lucky here. They didn't all get in a match at the same time, so sometimes that's going to happen, right? Our rule set isn't going to prioritize all of these players getting into a match. So let me try again. Let me try to, I'm going to press escape on all of these clients here, and I'm going to try to do that again. So click on the join game button really fast on all 4 of these clients. So I'm going to start again. Let's do this. Can we all get in a match? It's going to be really difficult. Oh, and we were not able to get into a match. Okay, so let me try one more time here. I know it's going to be really hard because it's not easy. Again, you got to be really fast when doing this. So let me try again. Click. Can we get all 4 of these in a match? Doesn't look like I was able to get all 4 of these in a match. Okay, this is okay though. I was able to get the next best thing. I was able to get the other 2 players to backfill this match currently really quickly. So okay, so we have 4 players in the match. That'll do. But again, keep in mind that you are able to get 4 players in a match based on, again, let's say if 4 individuals started a matchmaking request, you know, on their own, like literally around the same time, then these 4 players, they have a chance, again, if the rule set allows for it, to join the same match. But the test I wanted to test is, okay, let's say if 3 of these players left, right? So maybe we could get the next best thing. I'm gonna press escape on 3 of these clients. So right now there should be a backfill request now, including this one player, this one sole player. So the question is, can I backfill a request to make this match full? And I believe the answer is yes. So let me, again, we gotta do this really quickly. So you gotta click join game on these 3 clients really fast. No, see, I didn't do it fast enough. Okay, so, and now these other 2 guys got into their own game session, so that's not gonna be good either. But let me press escape here. This is a terrible test, but trust me guys, it is possible. You just gotta be really fast. So right now, let's see if we can backfill the other match with these 2 players. So I'm gonna try that right now. Okay, so we're able to still backfill the match. Again guys, it is possible, but it's just one of those things to keep in mind. Like backfill and creating matches with a certain amount of players, it's very it can be very random at times, like non-deterministic, because your rule set is basically going to determine, okay, do we backfill this, do we prioritize backfilling this request using these new players that are looking for a match, or do we prioritize putting these new players looking for a match into their own match? And that's the question. Also keep in mind that we only have 5 server processes on one active instance running right now. So theoretically, we can only have 20 players max in games at a time, because each match can have 4 players at most. So if you have more than 20 players looking for a match, then some of those players will be able to be successfully placed into a match by flex match, but they won't connect to the server because one isn't available. So you may notice in these kinds of scenarios that clients in the main menu map will have the text saying currently searching for a game in the middle of the screen for more than 1 minute. Even though the currently defined amount of time before a matchmaker request, including backfill requests, by the way, timeout if they don't lead to an event. update of type potential match created. But even if a ticket reaches the potential match created stage, that doesn't guarantee the ticket to reach matchmaking succeeded status if all the available server processes are currently in use. So tickets in this case may seem that they are frozen because they could be a potential match created stage for a long time. And when they time out in that stage, I don't believe a message gets sent to the SNS topic, but I could be wrong. And this is why GameLift made a useful auto-scaling solution to combat this issue to ensure that you always have enough available server processes. And we will hopefully go over this in a future part of the tutorial. But yeah, also, I kind of addressed the fact that backfill may not always happen in certain scenarios. So let's, I guess, just wait for this game session to finish. Let the counter go down all the way down to 0, and then a winning team will be chosen at random, and then we'll just check in DynamoDB if the match result was indeed recorded for this match. I believe before we started this match there were 33 results in that table, and the results in those tables don't disappear. So if everything worked, there should only be 34 results, because again, those other game sessions where we made but left really quickly, those shouldn't lead to match results being recorded, because they didn't go the full duration. Because again, once those players left the game, the game session should have terminated, because it should have realized, okay, there's no one in this game anymore. Okay, let's go to the DynamoDB dashboard, specifically the match results table, which we are currently looking. Let's get rid of this filter, and let's just refresh the amount of items in here. So how do I get rid of this filter? Scan, cancel changes, I guess. I don't want this filter anymore, so can I just do this? Can I refresh now? Oh, start search. So to get rid of a filter, you gotta actually search again. That's kind of weird. Okay, so we have 34 items. Like I said, that's the exact number we expected. Now let's actually look at the specific match result that we're concerned with. So let's go to the game of console, specifically the fleet with all the game sessions. So as you can see, a lot of game sessions were made here because we were trying to do that backfill, and sometimes we wouldn't be able to backfill, which is normal, right? Because it always depends on the rule set. But let's look at the latest game session that lasted for more than 4 minutes, because that one actually led to the picking of a winning team. And then let's get the game session ARN, copy that value. Let's go back to DynamoDB. Let's add that filter again for the attribute set to ID, and then for the value, just paste in that game session ID and press start search. Of course, we have a match result for that game session. And let's look at the losing team. So yeah, that was the Cowboys, and the winning team was the Aliens. That does indeed look correct. And I just want to reiterate, even though I've said it so many times now, it is possible to backfill a match with one player, with 3 new players, with one single backfill request, not 2. And it is possible to create a new match initially with 4 players without a backfill request. I just couldn't do it in this video because my hands were too slow at clicking buttons, and my guess is that the rule set just didn't like me today. But with all of that finally said, that is pretty much it. Guys and gals, that concludes all the major long hours of coding that we have to do for this tutorial project. Remember, all the code will be in the description, or all the code will be in a GitHub repository linked in the description below. Congratulations on sticking to the tutorial series all the way through and making it this far. Really appreciate you guys so much for watching and leaving feedback. Note that this isn't going to be the last part of the tutorial series. We still have other non-coding related things that we have to go over, such as remotely connecting to our Windows EC2 instance that is hosting our server processes. We also have to go over making a Linux server, because Linux on GameLift is cheaper than Windows. We have to go over auto scaling and pricing, and if we have time, we can also work on an Android client to show cross-compatibility between clients being possible. Basically, can we have an Android client and a Windows client in the Windows or Linux server process hosted on Amazon Web Services. But before I sign off, I just want to give an extra thank you to a lot of people, starting with our patrons on Patreon. I'm just going to name off all the names of the patrons that we currently have. So special thanks to Ahmad Rashad, Morgan, Heidemann, Elise, Diego, Eduardo Camacho, Adrian Vergara, BioBlaze Payne, Demas, Evan957, Lucas Moskin, Rick Morgan, Twin Assassin, Garf Snacks, Keith Perry, and Solartrix. Again, those names that I just read off are our current patrons, but I also want to, of course, acknowledge our past patrons, as well as all the various people who have donated to us on PayPal. Also, I want to thank all the people who tuned into our streams when we were working on making these tutorials, because when you guys watch us, that helps us. And I specifically want to thank these stream viewers for spending a lot of time watching us. So I want to thank Amelis, Pivotman, Beast, Baraka, Mikkel, Leo, Shane, Kaisaki, and anyone else who watched us live working on the tutorial project. And lastly, I just want to thank everyone in our Discord for contributing to amazing discussions, feedback, and support. Please join our Discord if you are not currently in it. Links will be in the description below. Thank you to the AWS staff who have been super supportive throughout this process. Thank you to everyone on the AWS Game Tech forums, specifically of course Pip, because I think, to be honest, he's probably answered the majority of my questions. But thank you to everyone in the community, because I've seen forum posts that weren't answered by Pip, but they still helped me tremendously, and even to the people who asked the questions too. And of course, thank you to the entire GameLift team for making and creating such a great product. And now that is pretty much it. Of course, if you have enjoyed this tutorial series, please subscribe to the channel, leave a like on the video, consider supporting us on Patreon or through PayPal, and hope you guys have a spectacular day.